Alright girls, so these are some review problems for linear and angular speed. I'll start with number 2. A satellite 290 miles above Mars' surface makes 1 revolution every 2 hours. What is the linear speed in miles per hour if the radius of Mars is 2,110 miles? So right now, the one thing that strikes me right away is here. We've got 1 revolution every 2 hours. So I know I've got 1 revolution for 2 hours. That's that revolution speed we talked about in class. And the best thing to do with the revolution speed is get it out of revolution, and we want to get it into that angular speed. So remember our conversion factor, that 2 pi radian equates to 1 revolution. And I know when I do this conversion that my revolutions will cancel, and I've got radians over hour. And if I do 2 pi divided by 2, okay, you can probably do that pretty easy, but if you want the decimal, if you're just not thinking, 2 pi divided by 2, you've got 3.14, or pi, if you will. And since we're looking at radians over hours, I know that's my angular speed. Now, that's fine and dandy. We've got the angular speed. I want the linear speed. And linear and angular speed are going to tie together through that equation. Linear speed equals angular speed times radius. Okay, we're looking for that linear speed. My angular speed was pi, or 3.14 radians per hour. And then that radius was up here, the given, at 2,110 miles. Now remember, when you multiply the angular speed times the radius, you get linear speed. So we're going to be looking at miles per hour for our unit. And that radian, that invisible label, will disappear. So I just need to take that 3.14 or pi times 2,110. And I've got 6628, as you can see. So my linear speed will be 6628.76 miles per hour. Okay. I double check. I see that they want my linear speed in miles per hour. So I know that this particular answer is in the correct